Today we will continue with where we left off from the previous lesson, and if you guys have not seen it, you can click the link above. It is about proving trigonometric identities. So in this lesson we're going to be looking at solving trigonometric equations. Now I've told you guys before this that in the past year papers, anything to do with trigonometry mostly consists of these three types of questions. So every time you hear the word solve, it simply means to find theta. Now bear in mind, we are learning trigonometry, and trigonometry is all about angles. So when we solve any trigonometric equation, it means to find theta, or the angle involved. So we're going to be looking at a few past year questions on solving trigonometric equations specifically, but before that, it is very important to have a good knowledge on these few things that you would need. If you know these things, you can solve them better. The first one is basic trigonometric identities. Now these are given on the front sheet of the exam paper. The next thing that you will need to know is the quadrant signs of trigonometry. So I'm sure you guys know that in the first quadrant all is positive, second quadrant only sine is positive, third quadrant only tangent is positive, and in the fourth quadrant only cos is positive. So you have many acronyms to remember them, like add sugar to coffee. And one more thing that is needed is to find the corresponding angles. For example, if theta is the angle in quadrant 1, the corresponding angle in quadrant 2 will be 180 minus theta. In quadrant 3, 180 plus theta. And in quadrant 4, 360 minus theta. So it is your ability to put all of this together, the signs, the corresponding angles, using the right identity, that will lead you to solve trigonometric equations. Feel free to pause this video at any time if you would like to attempt these questions before we do them together. As you can see, this question consists of three equations that needs to be solved. The first thing to take note is the domain. Sometimes the answer is required in degrees, and sometimes in radians. In the first equation, we try to reduce the types of different trigonometric functions. So if you notice here, we have cosecant and we have cotangent. So it is better to reduce all to the same type, either all to cosecant, all to cotangent, all to sine, just one type. So how can we do that? So looking back at the three basic trigonometric identities, notice identity number 3. We have cotangent square here, which means we can change cotangent square x in terms of cosecant square. So since cotangent square plus 1 equals to cosecant square, it means that cotangent square is, okay, by rearranging the terms, cosecant square x minus 1. Now guys, this is a very important step, okay, as it allows our equation to be just in one term all throughout cosecant. Okay, so in most trigonometry equations, try to do this. Look at the identity, choose the right one, if possible reduce it to just one type. Let's expand this now. Since we can expand it, we have 2 cosecant square x minus 2 minus 5 cosecant x minus 1 equals 0. Okay, now I'm sure you guys realize that this is actually a quadratic equation in terms of cosecant x. 2 cosecant square x minus 5 cosecant x minus 3 equals 0. So it is very clear here that we have a quadratic equation, ax squared plus bx plus c equals 0. Now, sometimes it's easier to replace cosecant x or whatever trigonometric function with just a single alphabet. So, for example, let us replace cosecant x with u temporarily. Okay, so it helps us to be able to factorize our equation, okay, nicely without having too much fuss around. Okay, so we replace u, okay, as cosecant x. Now, as in all quadratics, we factorize them. Okay, so we can factorize this quadratic equation into 2u and a u and a 3 and a 1, okay, minus plus. Okay, so what do we have here? Okay, are two factors, which gives us u equals negative half or u equals 3. Okay, now guys, bear in mind that u is not our answer. Okay, we have just used u as a temporary measure, okay, to replace a longer term cosecant x. Okay, so we have to use and replace back, okay, because cosecant x is the original term. Okay, changing to u just helps us to make things look simpler. Okay, so bringing back cosecant x will be equal to negative half, or cosecant x will be equals to 3. Okay, and now we have to solve and attempt to solve both these simple trigonometric equations. So knowing that cosecant x is actually 1 over sine x. So 1 over sine x is equals to negative half. 1 over sine x is equals to 3. Okay, by cross multiplying this part, we get 2 equals to negative sine x, okay, or sine x equals negative 2. This part, by cross multiplying diagonally, we obtain 1 equals to 3 sine x, or sine x equals to 1 over 3. If you look at sine x equals negative 2, there will be no solution obtained from this part. Why? Okay, because the lowest point, okay, or the amplitude is minimum only at -1. If you notice the sine graph, okay, the lowest point is -1. Thus, there are no angles that will give us a sine value of -2. So this part, no answer. Okay, it means that only the second factor will give us an answer. So looking at sine x equals to 1/3, it is positive 1/3, which means our answer is in quadrant 1 and quadrant 2. Okay, take care of the sine first. Now, by using my calculator, inverse sine of 1/3 will give us an acute angle of 19.5 degrees. Okay, but this is not the only answer, because sine is also positive in quadrant 2. Okay, so to obtain the second value, we have to remember this chart. Okay, so our theta in quadrant 1 is 19.5. Okay, S, sine positive in quadrant 2, which means 180 minus our value here. Okay, so 180 minus 19.5 gives us 160.5 degrees. Okay, so both our solutions fall into the domain of 0 to 180 degrees. Part 2. For this equation, we notice that the angle is 2y. Which means we have to find y as the final answer. Okay, now this is called a double angle. Now for this question, what we can do is we can bring this term here over to the right, which means to change it to positive for sine 2y. Okay, we can apply tangent, which means I divide. Okay, I bring divide across. So what happens here is this 4. Okay, I take 5 divided by 4. Okay, which means bring over, it's divide, and we have sine 2y divided by cos 2y. Now this is also a common question that is asked beside the quadratic ones. Okay, so what do we have here is, because we have sine over cos, okay, remember that sine over cos is actually tangent. Okay, this is also frequently used. It's frequently used all throughout, where tangent theta in general is sine theta divided by cos theta. Okay, so this theta can mean anything, and in this case, if you notice, it's 2y. So we apply sine divided by cos, and it becomes tangent. So this makes it into just a single trigonometric function. Okay, that's what we always try to achieve, okay, when solving trigonometric equations, because the more if you have tangent or sine and cos all at the same time, it will we can't solve it. Okay, we need to bring it down to just one. Okay, so this is always what we want to achieve. Okay, having a single type of trigonometric function, whether it's sine, cos, tangent, or secant, cosecant, or cotangent, just one type. Okay, now since we are already at this point, this is considered a simple trigonometric equation. Okay, we have to apply 3 steps. First of all, look at 5/4. Okay, it is positive, right? It is positive for tangent. Okay, so if you look back at our quadrant, okay, earlier on, our quadrant indicates that positive tangent is in quadrants 1 and 3. Okay, so our answer will be in quadrant 1 and quadrant 3. Yeah? So first step, check whether it's positive or negative, okay, for the given trigonometric function. So this case is tangent positive. Okay, so bear in mind that answer will be in quadrant 1 and quadrant 3. Now our next step will be, okay, to find the angle, just the angle, which is 2y. Okay, and we have to apply shift tangent or inverse tangent of the value, which in this case is 5/4. Okay, so most of these steps are systematic, so try to follow them, okay, as you go down. Okay, the same pattern. Okay, so use your calculator to find the value of inverse tangent 5/4. Now the calculator always gives you the answer in quadrant 1 only, okay, which in this case is 51.34. Okay, but don't forget we have another answer, because 51.34 is in quadrant 1. It is the acute angle. Okay, but we know that since tangent is also positive in quadrant 3, we have to find the corresponding angle. Okay, and back to this chart again. In quadrant 3, the angle is 180 plus the acute angle, which in this case is 51.34. So 180 plus 51.34 gives us 231.34. Okay, but this is 2y. We always want the solution just for a single y, okay, or a single x. So this can be done by dividing both of these answers with 2, and it should give us 25.7 degrees and 115.7 degrees. Okay, so we always try to use identities to bring it down to a simple trigonometric equation, and we have to solve it, okay, using the 3 steps. Check positive or negative, inverse tangent, find the other angle, and make sure your answers are in the given domain. Now this question, we have to solve it in radians. Okay, so remember that 2 pi radians is actually 360 degrees. Okay, so anywhere between 0 and
2 pi, which is in 1 full revolution. Okay, so if you observe this equation, nothing needs to be done anymore. You do not have to apply any identities, okay, or because it is already a simple trigonometric equation, just one type, right? It's just a cos. This is our angle now. It is z plus pi over 6 equals negative half. Okay, so once we are down to this stage, okay, we just have to apply the 3 steps. First of all, okay, notice that this is negative value, okay, and it is negative for cos, okay, which means that our answer would lie in quadrant 2 and quadrant 3. Cos negative, answer quadrant 2, quadrant 3. Yes? Okay, so since we already know where we should be looking out for it, secondly is to apply inverse of cos. Now, but be very careful, because okay, we do not want negative angles in this case. So when you use your calculator to inverse cos, just put in the inverse cos of half. Okay, and before all this, you have to set your calculator to radian mode, okay, so that we do not have to convert from degrees to radian. So change your calculator to radian mode. Okay, so ignore the negative, okay, and find inverse cos of half. And inverse cos of half gives us an angle of 60 degrees, or pi over 3 radians. Okay, so now we know that 60 degrees is a special angle, okay, because it can be left as a very nice exact form of pi over 3. Now this answer here is not the final answer, because we only call it as a reference angle, okay, which means because it is in quadrant 1, okay, we can use it to find the other angles in quadrant 2 and quadrant 3. Okay, but anytime you see negative, please be careful when you inverse cos, inverse sine, or inverse tangent. Okay, so now, okay, we are ready to go. So our angle will be z plus pi over 6. So pi radians minus pi over 3 radians will give us 2 pi over 3 radians, and this is our angle in quadrant 2. Okay, and in quadrant 3, okay, to get the corresponding angle, we take pi plus the acute angle, which is pi over 3. So it gives us 4 pi over 3 radians. Now, bear in mind, you can also leave your answer as a decimal in 3 significant figures. Okay, but since we are dealing with special angles here, okay, it is best to leave it as a fraction in terms of pi. Okay, so one last step. Now, to find z, okay, we have to subtract pi over 6 from each of these 2 angles here. Okay, so we will have 2 pi over 3 minus pi over 6. Okay, and the other one, 4 pi over 3 minus pi over 6. Okay, so our solution will be z equals to pi over 2, 2 pi over 3 minus pi over 6, and 4 pi over 3 minus pi over 6 gives us 7 pi over 6. Alright, now let's take a look at another question. This one comes from the summer of 2009. Please feel free to pause this video, okay, and attempt this question yourself first. Now, we have seen that in solving equations, our aim is to find the value of x, and x is the angle that satisfies this trigonometric equation. Now let's look at A1. We can bring this 3 cos x over to the right hand side, and it becomes 3 cos x. Okay, the reason doing so is because we want to develop sine x divided by cos x, and bringing all the numbers to the right hand side, we get 3 divided by 2. Now, this is also frequently used because sine x over cos x gives us tangent x. So from sine and from cos, there is a way to make it into tangent x. That's what we want. Okay, we always want to reduce it to just one type, and 3 over 2 is 1.5. So when you guys arrive at this point, a simple trigonometric equation, it's time to apply the 3 steps. Okay, the first one is we observe that this is tangent and 1.5 is positive. So a tangent positive will lead us to angles in quadrant 1, as all is positive there, and in quadrant 3. Okay, so we always need to know the location to find these angles. Okay, once we have done that, second step will be to find x, and that is to inverse tangent 1.5. Okay, and using the calculator, we would get an answer of 56.3 degrees. Now, the calculator always gives us the acute angle, okay, which is the answer in quadrant 1. Now, there is another angle in quadrant 3, and to get the answer in quadrant 3, we have to take 180 plus 56.3. Okay, and that gives us 236.3 degrees. Now, in question A2, there are 2 different types of functions here, sine and cos. So always we try to reduce it, okay, into one type. Now, we can do so because remember that our very first trigonometric basic identity is sine square y plus cos square y equals to 1. Now, what we want is sine square y. So sine square y, by rearranging the terms, will be 1 minus cos square y. So we replace 1 minus cos square y into the equation so that all our terms are in cos y. Okay, so we have 2 from basic identity number 1. We have 1 minus cos square y, and carry on with the rest. Okay, so expand it. And arrange it in the general form of a quadratic equation. Now, let's make this coefficient positive. It's shifting all these terms over to your right, and we will get 2 cos square y plus 3 cos y minus 2 equals 0. Okay, and this is a quadratic equation in terms of cos y. So we can, okay, temporarily replace cos y with u, okay, to make our quadratic look much simpler. So cos square y becomes 2u square plus 3u minus 2 equals 0. Okay, so this quadratic equation can be factorized to u. Okay, factorize and put your signs correctly. And we have u as half or u as negative 2. Okay, so once we have obtained u, we can replace it back with cos y. Now, if you guys are familiar and you do not have to use this substitution and you can factorize it straight away, that's even better. Okay, so we have u, which is cos y, equals to half, and on this side we have cos y equals negative 2. Now, from this part, we will have no feasible solutions for y, because the amplitude is way below the minimum amplitude for a cosine graph, which is negative 1. Okay, so there will be no solutions from this part. Okay, and our solutions will only come from the first part. So once we are down to a simple trigonometry equation, notice that it is positive half for cos. So cos positive indicates quadrant 1 and quadrant 4. Okay, so by using the calculator, inverse cos of half, okay, will give us two values. Okay, the first one, the acute angle is 60 degrees, and the corresponding angle in quadrant 4, guys, don't forget, will be 360 minus 60, which gives us 300. So the solutions for this question will be 60 degrees and 300 degrees. Now let's take a look at 11b. Sine 2z plus 1 equals 0.9. So the first thing to do is, okay, change your calculator mode. Okay, your calculator mode has to be changed, okay, from degree to radians. Now this is very important, okay, because we can get our answers when we use the calculator to inverse sine, and it will give us radian straight away. And remember, always, what unit must you set your angle in? Okay, is it in degrees or in radians? Okay, now we can solve this straight away. Now bear in mind that z is from 0 to 3 radians. So 0 to 3 radians is basically quadrant 1 and 2, because 180 degrees is pi radians, or 3.14. Okay, so just keep that in mind. So 2z plus 1 inverse sine. Okay, use your calculator to inverse sine. So what will you see on your calculator? Now it will give us 1.12, okay, which is our angle in quadrant 1. Okay, but don't forget, again, this is 0.9 and it's positive, and we are looking at sine, which means our answer is sine positive, which is quadrant 1 and quadrant 2. Okay, so the calculator gives us quadrant 1, the acute angle. So we must find the angle in quadrant 2. Okay, and in quadrant 2, since we are in radians mode, will be to take pi, or 3.142, minus 1.12, which is 2.02 radians. Okay, so that is the value for 2z plus 1, 1.12 or 2.02. Okay, and all we have to do is just to find z. So subtract 1 from both of these angles, and to find z we divide 2. Okay, so our answer finally will be 0.06 radian, okay, and 0.51 radian. Okay guys, so that's what we have for you in this lesson regarding solving trigonometric equations. Practice makes perfect. Attempt as many questions as possible, and if you would like me to go through any questions with you, just write it down in the comments below. So thanks for watching. I'll see you in the next lesson.